In this video, we'll be finding the zeros, or the factors or roots, of each quadratic function shown here by factoring. So what we'll first need to do is identify the type of factoring, then use that to solve for x. So if I have x squared plus 7x plus 12, the first thing I want to do is identify the type of factoring this will need to be. Visually looking at this one, I can see this one's going to be product and sum, which means I'll be looking for two numbers that multiply to give me 12, but then add to give me 7. Going a little bit farther with that, I know that 3 times 4 is 12, and I know that 3 plus 4 is equal to 7. So factoring this, I would have x plus 3 and x plus 4 equal to 0. If I need to solve this, I'm going to use the zero product property now, which states that either this bracket equals 0 or this one, either of which would make this equation true. So I'll take x plus 3 and set that equal to 0. And I'll also take x plus 4 and take that equal to 0. Solving the first for x, I get x is equal to negative 3. Solving the second for x, I get x is equal to negative 4. What's important to realize is that each time we're going to solve a quadratic and we're looking for the zeros, our function needs to be equal to 0. So when I have a function like I have in B here, where I have x squared minus x equals 72, a good idea to start that would be to take the 72 and move it to the left hand side. If I do that, I get x squared minus x minus 72 equal to 0. And now this looks very familiar because it looks very much like the product and sum I just did. The product I'd be looking for this time would be negative 72, and the sum is negative 1. If we think about that, we know that 8 times 9 is 72. If I make the 9 negative, then I get negative 72, and if I add them, I get negative 1. So here I'd have x plus 8, x minus 9 equal to 0. Solving using the zero product property, I set each equal to 0. So x plus 8 equals 0 gives me x equals negative 8. X minus 9 equal to 0 gives me that x is equal to 9. And I get two values. These are, in each example, these would both be considered roots, zeros, or solutions to the equations listed above.